Okay? So, let's make a relation. Let's make a scenario that we can model and represent in different ways. Okay? Go to page 282 in your book. The Canadian National Frog Jumping Championship, which I guess is a real thing, is part of a festival that is made out of French words. This annual festival is in St. Pierre, Jollies. I'm probably saying that wrong. Manitoba. The first champion, a frog named Jorge, jumped a distance of just over 2 meters in a single leap. That's about as tall as me. Good job, Jorge.
I didn't do that.
Assume that Jorge could maintain a distance of 2 meters on every jump, and that the total distance traveled from the start is measured after each jump. Consider the relationship between the number of jumps Jorge takes and the total distance the frog travels. Okay? I've kind of changed the questions a little bit after that paragraph because I wanted it to focus on something else. So I'm just going to read the notes here rather than reading what they have for the questions in the textbook. So A in the notes says, in words, write a sentence that explains the relationship between the number of jumps Jorge takes and how far he travels. What's the relationship between how far he goes and the number of jumps he makes?
The further he jumps, the farther he goes.
Okay, but by how much?
2 meters.
2 meters. Okay. So how could we say this in a proper sentence?
For every jump the frog jumps 2 meters.
Good. Okay, for every jump the frog makes, he travels 2 meters. Good way of saying it. Okay? For every... I'm going to move this over. Jump. It's kind of like George's. Jorge takes. He travels 2 meters. Good. We're going to create a table to compare the number of jumps Jorge has made and how far he has gone. Okay? So that's B. Here's your table. Number of jumps, we're going to just call that N. And total distance traveled, we're going to call that D. Alright, so the frog jumps 0 times. How far has he gone? 0 meters. The frog jumps 1 time. How far has he gone?
2 meters.
2 meters. The frog jumps 2 times. How far has he gone in total?
4.
4 meters. Is this hard yet?
No.
3, 6, 4,
8.
8, 5, 10, 6, 12. Get the idea? Pretty tough?
Yep.
No.
Yeah.
Okay. C asks us to choose 5 ordered pairs from the table and write them in a list. What's an ordered pair?
1 and 2, 5 and 10.
Good. It's a coordinate, basically. It's a point that you could put on a graph, and you list always a value in the left column first, comma, a value in the right column, and all of that goes in brackets, right? You've seen these before, I'm sure. So 1 ordered pair would be 0, 0. That just means 0 jumps, he's gone 0 meters. The next one would be 1, 2. 1 jump, he's gone 2 meters. We could skip down maybe to 3, 6. 3 jumps, 6 meters. 4, 10. 4 jumps, 10 meters. And let's just go 6, 12.
4, 8.
Yeah, thank you, 4, 8. Okay, so 4 jumps, 8 meters, 6 jumps, 12 meters. Good? Could we create more ordered pairs than this? Yeah, probably. We could just let him jump on into infinity until a truck ran over him. Something like that. That is cruel. Don't joke about that. D asks, what equation relates the number of jumps Jorge has to take and the total distance he has traveled? Another way of saying that is, what can I do so the numbers on the left here, to get to the numbers on the right. Times them by 2, right? So in an equation, if I let D represent the total distance that the frog has traveled, that would be equal to 2 times the number of jumps, n. D equals 2n. You won't spend a lot of time in this section learning how to make equations. That's really more the focus of chapter 7. But it's good to get an intuition for what equations do, what they mean. Right? It's showing a relationship between the number of jumps the frog has taken and how far he's gone. Okay? Now let's graph. Turn the page. Okay, we're going to plot some of the pairs that we chose in C. In fact, we're just going to take all the pairs from B, all the values that we had in our table, and we're going to plot them here on this Cartesian plane. The first thing we need is some kind of scaling, right? So I'm going to go up just by, let's see here, I need to have my y values go up to 12, right? Is that right? Yeah. The left column is always the x-axis. I should mention that. This is always the x-axis. This is always the y-axis. That's important. The left side is always the x-axis. The right side is always the y-axis. So I need to go up to 12 somehow. So if I go up by 2's, 2, 4, 6, 8. No, that's not going to work. 2, 4, 6, 8, 10, 12, 14. Yeah, that'll work. If I go up by 2's. So I'm going to go up by 2, and then 4, 6, 8, 10, 12, 14, 16, and then I'm pretty sure if I went up by 1's, that'll work nicely. Actually, I'll skip a space. I'll do every other square. Okay, there we go. And of course, down here is 0. All right, so let's graph this. 0, 0 is my first point. 0, 0. What's my next point? 1, 2. So 1 over 2 up. Good. Next point. 2, 4. Should be pretty obvious. 3, 6. Okay, just put them all on there. And there we go. Good? Okay. So just to review, we've taken the same relation, Jorge jumping 2 meters every time, or traveling 2 meters every time he jumps. We've taken that idea and expressed it 5 different ways. Right? One way was through words. The other way was through a table. Then ordered pairs. Then an equation. And finally a graph.
Whoa.
5 different ways to show the same thing.